Alright, so here we are in part 2 of lesson 12-1 on tangent lines. And this is just one example, shouldn't be too long, but it's kind of a tricky example, so I wanted to save it for a separate part. So this problem is on a bicycle chain. So if you look at a bike chain, next time you hop on a bicycle, you can notice that you're going to have two of these circles here with a chain going around both sides of it. Now, here's the question. We want to find the length of AB. We want to find the length of AB, which is this. I'll do it in like a orange color here. We're trying to find the length of that orange segment, AB. So the middle of each chain to each other. And all we're given is that the radius of the small circle is 5, the radius of the big circle is 6, and the length between the points of tangency is 20. Okay, so here's kind of the concept. We want to create a right triangle somewhere, and we're going to use the Pythagorean theorem. But this is where it gets kind of, you have to know to do this because it's a little weird. I'm going to draw a segment that is parallel to the segment connecting to the points of tangency, which creates a rectangle. Okay? It creates a rectangle. And the reason I want to do that is now I didn't just solve it automatically. It would have been the lamest part 2 ever, right? A minute and a half of, oh, it's just 20. That's not it. We know that this segment is 20, but that's not AB because it doesn't go to B, right? It goes down here, okay? But we do know that this segment here, right here, must be 5. So just this part that I'm tracing in purple here must be 5, leaving us with this part here, which I'll highlight in yellow. This part here, if the whole thing is 6 and the purple part is 5, then this part must be 1. Right? So the yellow part, which that's hard to see, so the yellow part is a length of 1. Okay? Now what happens here? We can form a segment from A to B. That was terribly drawn. A segment from A to B that forms the hypotenuse of this right triangle here. So I'm going to kind of expand that right triangle because it's hard to see. So this is the purple part. In fact, I'll do it in purple so you can see what I'm doing. I'm just removing it from the picture above. I have the purple segment. That's 20. I have the yellow segment. That is 1. And I have the connection from A to B here, and that's what we're solving for. So we can call that, x if we want to. Well, now we just, set up the Pythagorean theorem. So we have, in fact, I'm going to put this on a separate page so that we can come back and see it and have more room here. So if you're confused as to where this came from, you can just rewind. Okay? So again, just to be clear, this segment here is 1 so you can see it. So we're going to set up Pythagorean theorem saying that 20 squared plus 1 squared equals x squared. And now it shouldn't be too bad. Okay? 20 squared is 400. 1 squared is 1 equals x squared. So you get 401 equals x squared. Therefore, x equals the square root of 401. Okay? So again, it doesn't seem like that crazy of a problem. It's not like mind-blowing or, it's not going to change your life by knowing how to find the distance between the center of, two circles. But it's a weird concept to piece together at first. This step here, where you draw this parallel line right there, that is not a natural step to take. It's kind of a bizarre step, right? But now that you know, once we create that parallel line that I'm pointing to with the blue arrow there, that purple line, it's parallel to the bottom, which creates a rectangle, which gives us this length here. And what we do with that length is we make it the base of the right triangle with a hypotenuse of AB. Okay? And we can piece together the rest of the triangle. Okay? So that's pretty brief. Brief part 2. If you have any questions on that, you can feel free to comment or ask questions in class if you're my student. Other than that, have a fantastic day, and yeah, hope you enjoyed. Hope you learned something new. Bye, guys.